Alright, so this turns out to be another Hopital rule problem. So to evaluate this thing, or to figure out that I need to use Hopital's rule, I want to try to plug in t equal to 0 and see if I can go with it. If I plug in t equal to 0, sine is 0 is 0. So I get 1 over 0 minus, and then this gives me 1 over 0 as well. So that goes to, if I look at that limit, that goes to infinity minus infinity. So in order to evaluate this thing, I need to use Hopital's rule, because that's one of the forms for Hopital's rule. The problem with this is that it's not, I need to have it in a 0 over 0 or infinity over infinity to do Hopital's rule, and it's not there yet. It's infinity minus infinity. So I got to do some work to get it there. I'm going to find a common denominator. So this is the same as the limit as t approaches 0 of open. My common denominator is going to be t sine t. And then I'm going to multiply the t by this for the first part, so that's going to give me t. And then I'm going to multiply the sine t by this to give me minus sine t. And then, so now I try to go ahead and plug in 0 for t, which gives me 0, minus sine of 0, which is 0 again. So I get that this goes to 0 over, and then here 0 times 0, so 0 over 0 again. Boom, now I can use Hopital's rule with it in this form. So this is, should write equals the limit as t approaches 0 of, the top is the easier to do. I get 1 minus cosine of t. In the bottom I have to use product rule. I'm going to actually do derivative of the second, which is cosine t, times the first. So that gives me t cosine t. And then plus the derivative of the first, t, times sine t. This thing's derivative is 1. So I get t cosine t plus sine t by using product rule. Now, I try to plug it in, right? So when I plug in 0, I get cosine of 0, which is 1, right? Which gives me 1 minus 1. So I get that this goes to 0 over. Now, if I get a number in the bottom, I get 7. Well, if I get like a non-zero number, so 7, 8, 10, whatever, in the bottom here, 1, then I know that the limit is 0, because it'll be 0 over something other than 0. But unfortunately, when I plug in t equal to 0, I get 0 times cosine of t, which is 0. And then sine t, well, that's 0. So I get 0 plus 0, which is, again, 0. And it's kind of a bummer, because I thought I was done with this problem. But we have to go and apply Hopital's rule again. So I should probably write that I hopped it. So I'm going to hop it again. So this is equal to limit as t approaches 0 of, now I got to do derivative of the top and then derivative of the bottom. The derivative of the top, well, this goes away, and this gives me, actually gives me positive sine t. So I get a sine t in the top over. Got to do product rule for the first part, so I get derivative of the first, which is 1, times the second, cosine t, and then derivative of the second, which is minus sine t, so minus sine t, times the first, which is t, and then I got to do the derivative of this thing, the sine t there. So I get, my fraction bar keeps going, get a plus cosine t. So you should see here that I have that this is equal to the limit as t approaches 0. I'm not doing Hopital's rule, just collecting parts of my fractions. I get a sine t in the top over, I have 2 cosine t's this one, and this one. And then I have a minus t sine t. Now it's collected. I want to try and plug in my t equals 0 again. Plug in t equal to 0 to the top. Just like the last one, I get 0. And then this is where it works out the way we want it to. Plug in 0 to t here. I get 2 times cosine of 0, which is going to give me over 2, because the cosine of 0 is 1, minus, well, this thing right here gives me 0 times 0, which is going to be nothing. So 2 minus 0, which is 0 over 2, which gives me my final answer of just straight up 0.